You're watching Code Like an Architect series with Adil Ata on ArchiWisdom. Test 5. We have to implement the functionality to book an appointment. The requirements look like this. Validate customer details. Detect and prevent spam requests. Assign a meeting agent. Enrich customer data. Set reminders. Track the event. We already track events for all features, which are later used in analytics and other monitoring tools. Now, there are two variants of this appointment booking functionality. We have a basic version and a premium version. The basic version looks like this. It validates customer details. It has basic support for detecting spam requests. It assigns a meeting agent using the round-robin algorithm. It doesn't offer data enrichment functionality. It sends a reminder 10 minutes before the meeting, and it tracks events. On the other hand, the premium version looks like this. It validates customer details too. It has an advanced support for detecting spam requests based on a paid third-party service. It assigns the most appropriate agent using an AI-powered solution. For data enrichment, it uses a paid third-party service to retrieve additional data based on location. Specifically, we pass a city and it determines the currency and languages spoken. It sends reminders based on user-specified settings, and it tracks events too. We have already seen multiple times in this series how developers typically approach such programming problems. Not all, but many developers tend to skip the analysis phase. They jump straight into development. They don't break down problems into components. Instead, they usually implement all the functionality in a given sequence. At most, if a method becomes too large, they break it into smaller methods or rely on the high-level organization that is already given. Now let's code like an architect. Architects usually don't implement functional requirements, but when they do, they start with analysis. They break down problems into smaller, manageable parts. They design individual independent components and connect them in a loosely coupled manner. Remember the examples from my first video, Code Like an Architect? This is a car. You can see it as a single object. Or you can break it down into its components: wheels, engine, body, seats, and more. If you see it in components, you can create different types of new vehicles simply by changing the properties of each part and connecting them in different ways. Just by altering the number and sizes of the wheels alone, you can design countless types of vehicles. By changing the properties of wheels, you keep innovating. This is possible only because you are thinking in components. Thinking in components is an architectural skill, and indeed a very important one. Now, let's look at these requirements. We have two different variants of appointment booking. Let's think in components. We have a validator, a spam checker, agent assigner, data enricher, a reminder scheduler, and an event tracker. And that's how the two variants look like. In the basic package, we have a validator, a local spam checker, a round-robin agent assigner, no data enricher, a fixed 10-minute before reminder scheduler, and a cloud-based event tracker. In the premium package, we have the same validator, a paid third-party spam checker, an agent assigner that assigns the best possible agent using an AI-based algorithm, a paid third-party data enricher, a reminder scheduler that works using user-specified settings, and the same cloud-based event tracker. Let's code. Now let's see some scenarios. The third-party spam detector service used in the premium package has turned out to be very costly. Though it's a great service, we still want to use it, but we need to minimize the cost. How can we do this? That's how our components look today. We can achieve this by making the following change. We will call the local spam checker first, and then only use the third-party service if the local spam checker recommends it. Scenario 2. We want to replace the AI-powered agent assigner with a more advanced AI-based version of it. How will we do this? We will write the new implementation, remove the existing connection, and make a new connection. Next, we have a performance issue. For data enrichment, we pass the name of the city to the third-party service and receive currency and languages spoken. The problem is this service often responds very slowly, increasing the total time taken for appointment booking. We also noticed that we repeatedly call this service with the same values, getting the same data again and again. We can improve performance by locally caching the data. We need to modify our data enrichment component to add caching support. Next, we are facing an error in event tracking. Too many requests. This is happening because the cloud service we are using is rate limiting the number of requests we can send per minute. Let's say we can only send 1,000 requests per minute. Since we are heavily using this service and our usage has increased, we are now seeing this error. We reached out to support and they said this is a hard limit. Now, what can we do? Also remember that this event tracker component is being used for almost all the features. How will you solve it? In this scenario, we can do load leveling. We will replace the event tracking component with a load leveled version of it, like this. Instead of calling the cloud service directly every time an event is tracked, we will queue the request. Then a periodic executor will run every minute, dequeuing 1,000 requests at a time. It will then send these requests to the cloud-based event tracker, respecting the throttling limit of the cloud service. When you break down a problem into components, you think like an architect. By designing individual and independent components first, you gain complete control. You can connect them in different ways. You can create different variants. You can completely transform a component. You can replace or upgrade a component without disrupting the entire system. You can isolate complexity. You can handle even the most complex requirements with ease, keeping your code clean and maintainable. When you approach programming this way, you gain the ability to innovate. And ultimately, you don't just code. You code like an expert. You code like a master. You code like an architect.